Hi everyone. Um, we're gonna learn to find the intersection of three planes if it exists. Find the intersection of each set of three planes if it exists. Also give a geometrical interpretation of your answer, which we're gonna use on one of our pictures to do it. So as soon as you get a question like this, the first thing you're gonna do is analyze the normals so that you can predict what your solution may be, or if there's no solution and no need to use a matrix. So I'm looking at my three normals and I don't see any scalar multiples. So the next thing I'm going to do is check and see if the normals are coplanar. So I'm going to do n1 dot n2 cross n3, which is going to give me 3, negative 2, dotted with the cross product of those two. So that's going to give me 4 minus 12, which is negative 8. Negative 6 minus 20, which is negative 26. And negative 10 minus 1, which is negative 11. And then I'm going to get negative 24. Minus 78 plus 22, which is going to give me 76. So since we didn't get 0, we know automatically that there's a point of intersection, and it's going to be like this arrangement here where the three planes meet. Sorry, right where my pencil is going to be right there in the middle. Okay, so once we know there's a point of intersection, we're going to enter our equations into the matrix. So it's going to be an augmented matrix again. So we're going to put our coefficients of x in the first column, our coefficients of y in the second column, our coefficients of z in the third column, then a line that represents our equal sign, and then we move the constants over to the other side, so it's going to be positive 14, positive 10, positive 9. And we're not going to completely row reduce this matrix. We're just going to get an L shape of zeros in this bottom corner. Okay, and the first zero we want to get is where the 5 is. So we want to get a 0. Here's row 1, row 2, and row 3. And what we want to do is get a 0 where that 5 is. That's going to be our first step, getting a 0 there. And we know we can use elementary row operations to do that. And we know when we're trying to get zeros, it's always adding or subtracting multiples of rows. So what I see, because I've got a 5 here and a 1 here, I can replace this row with 5 row 2s. I always start with the row I'm going to change and subtract, 1 row 2. My bad. 1 row 2 minus 5 row 3s. And that's going to give me a 0 in the spot that I want. So I'm going to keep the first row the same. Row 1 is going to be the same. And row 3 is going to be the same. Here I'm doing row 2 minus 5 row 3s all the way along. So I have 5 minus 5 is 0. 1 minus 5 times negative 2, so that's going to be 1 plus 10, which is 11. Negative 6 minus 20 is going to give me negative 26. And 10 minus 45 is going to give me negative 35. So again, make sure you double check, use your calculator, and make sure those numbers are correct. So the next thing we want to do is get a 0 where this 1 is right now. So we're making this L shape of zeros down here. Okay, so we've got the top of the L first, then the bottom, and then the side. So we want to make that into a 0. That's our next objective. So we can't use a row that has a 0 above the 1. So we have to use row 1 to get our 0 in this case. So I'm going to do 3 row 3s minus row 1 to get a 0 where that 1 is right now. And I'm going to keep row 1 and row 2 the same. So 3 row 3, so 3 times 1 is 3, minus 3 is 0. 3 times negative 2 is negative 6, minus negative 3 is negative 3. 3 times 4 is 12, minus negative 2 is 14. And 3 times 9 is 27, minus 14 is 13. And then our next step, we want to get a 0 right here where this negative 3 is. We want that to be a 0. So notice that I can only use row 2 and row 3. Once I've got the zeros here, I can't go back and use row 1 anymore because it would any multiple of it would undo this 0 here. So if I was like, it's really tempting to do row 3 minus row 1, but if I do that, I would have 0 minus 3, and all of a sudden that 0 would go away. So that's I can't do that, even though it looks really tempting. So instead I have to use these 2 rows. So I'm going to leave row 1 and row 2 the same. And to get a 0 there, I'm going to have to take 11 row 3s and add 3 row 2s. Because then I'll have 11 row 3s would give me negative 33 here, and then 3 row 2s would give me positive 33 here, and when I add them, I would get 0. Okay, so I'm glad we used this example because it is really tempting to use row 3 and row 1, but you can't because then you would undo this 0 that you've already made. Okay, so 11 times 0 plus 3 times 0 is still going to be 0. We don't want to undo a 0. And then we said that 11 times negative 3 is negative 33, plus 3 times 11 is 33, so we get our 0 here. Now I'm going to use my calculator. So I'm going to go 11 times 14 plus 3 times negative 26, and that gives me 76. And then I'm going to use my calculator here, and I'm going to do 11 times 13 plus 3 times negative 35. And that gives me 38. And once I have those 3 zeros there in this L shape, I'm going to stop and just read the matrix and let the reading of the matrix help me find my point of intersection. So I'm going to read it from bottom to top instead of top to bottom. So this row tells me that 76Z equals 38. Or if I divide both sides by 76, I get that Z is 1/2. Then if I read the second row, it tells me that 11Y minus 26Z equals negative 35. But I already know that Z is 1/2. So I can come back here and back substitute in Z being 1/2 here, which is going to give me 11y minus 13 equals negative 35. Add 13 to both sides. 11y equals, so negative 35 plus 13 is negative 22, which works out nicely. Divide by 11, and you get y equals 2, negative 2, sorry. So now I know z and y. So now I'm going to go and find x using back substitution as well. So that row tells me that 3x minus 3y minus 2z equals 14. But I already know y is negative 2 and z is a half. So I'm going to sub those in right now. So y is negative 2 and z is 1/2. And now I just need to solve for x. So I get 3x plus 6 plus 1 equals 14. I can subtract 6 from both sides and subtract 1 from both sides. So I get 3x is equal to oops, this was negative 1, my bad. This should be negative 1 here, negative 2 times a half, so that's plus 1, and that's plus 1. So I'm going to get 8 plus 1 is 9 here. So x turns out to be 3. So now we know our point of intersection is, so make sure you put your x first, your y second, and your z third. So that's the point where those three planes intersect. And we know that the picture is going to be this one. So it says, give a geometrical interpretation of your answer. So we are saying it's a point of intersection, but I'm also going to cut out this picture and just tape it on. Sorry guys. So this is what the geometric arrangement of our planes are going to look like. And our POI is like right there where all three planes intersect. Okay, so that's how you use matrix row reduction to get a point of intersection. We're going to do another example where we get a point of intersection. And then I have two practice questions that I would like you to try that both result in a point of intersection, so you can get that one figured out today, and then we'll move on to other types tomorrow. Okay, so here's question B. So first thing you would do is analyze the normals. Looking for scalar multiples, so these ones aren't. These ones aren't. No, so there aren't any scalar multiples. So now we're going to check n1 dot n2 cross n3, which is going to be 1, negative 3, negative 2, dotted with so negative 10 minus 6 is negative 16. Negative 3 minus 4 is negative 7. 12 minus 15 is negative 3. And then we're going to dot product, so negative 16 plus 21 plus 6 is equal to 11. So it's not 0 again, so therefore we have a point of intersection. So we're going to do the same thing we did. We're going to make an augmented matrix with our three planes inside. So the coefficients of x go in the first column. Coefficients of y go in the second column. The coefficients of z go in the third column. Then we represent our equal sign. And then we have to move these constants all over in this case, so their signs are going to flip. And again, we have our row 1 and our row 2 and our row 3. So the first thing we want to do is get a 0 where the 2 is right now. We want that L formation with 3 zeros, and we get this one first. So it looks like I could do, to get a 0 there, row 2 minus 2 row 1s. And then I'll leave row 1 and row 3 the same. So if I do row 2 minus 2 row 1s, I get 2 minus 2 is 0. Negative 5, it's going to end up being plus 6 is 1. 1 minus negative 4, or plus 4 is 5. And 3 plus 18 is 21. And then the next thing I want to do is get a 0 here. We want a 0, that's our second 0 we want to get. And then I can see that I'm going to have to combine row 3 and row 1 to get a 0 there. So it's going to be row 3 plus 3 row 1s. And then I'm going to keep row 1 and row 2 the same. Okay, so I'm doing negative 3 plus 3 times 1 is 0. 6, if it turned out to be minus 9, is negative 3. 2 plus negative 6 is negative 4. And 8 minus 27 is negative 19, I think. Yep, negative 19. Okay, so then the third thing, we want this bottom to be like an L of zeros. That's what we're going for. So we want to get a 0 here. But again, even though it looks really tempting, we can't use the top row because it would undo this 0 here. So we're trapped into using just between row 2 and row 3. So we leave row 1 the same and row 2 the same, and we're going to use row 3 and then plus 3 row 2s to get our 0 here. Okay, so 0 plus 3 times 0 is still 0. Negative 3 plus 3 times 1 is 0. Negative 4 plus 3 times 5 is 11. And let's use our calculator. So negative 19 plus 3 times 21 is 44. So now that I've got this L of zeros here, I can read my matrix. And remember, we start from the bottom. So the bottom tells me that 11z equals 44. So if I divide both sides by 11, I get z is 4. So I know that the z value at the point of intersection is 4. So now I'm going to read the second row, which tells me that y plus 5z equals 21. But I already know z is 4, so I can replace z with 4, which gives me y plus 20 equals 21, or the fact that y is 1. So now I know y is 1 and z is 4. Now I'm going to read the first row, which tells me x minus 3y minus 2z equals negative 9. But I can replace y with 1 and z with 4. So x minus 3 times 1 minus 2 times 4 equals -9. So x minus 3 minus 8 equals -9. X minus 11 equals -9. And we get x equal to 2. So that would mean that therefore, the POI is 2, 1, 4. And again, we know that that arrangement happens when the normals are not coplanar, as well as none of them are parallel. So I'm gonna tape on this picture to show my geometric representation. And for practice, I would like you to do from the practice questions, question 1 and question number 2A. They should both result in points of intersection, and I really want you to concentrate on how you use matrices and starting here, get the 3 zeros using row operations, and then reading the matrix and concentrating on being able to do that for a point of intersection. So when we pick up tomorrow, we'll go over other possibilities. But for now, I want you to focus on being able to do your normal analysis and then solve your matrix when it turns out to be a point of intersection.